Wow, a great crowd. So welcome to another Microservice Meetup. Big crowd today. I'm happy that we actually got rid of the wait list and that the room is packed. This is how it should be. I believe we have sufficient beer reserves, so no problems on that front. I'm very happy to have Vaughn at the Microservice Meetup. You're here for the second time, and this was one of the most uncomplicated arrangements with the speaker. Vaughn, I've noticed that you're in Munich for a workshop. Would you come for the meetup? Yes, sure. When? Okay. So thank you very much for being that upfront and being at the meetup. Vaughn has a 3-day workshop behind him, so he's a little bit exhausted, but I believe he will do great during this presentation. I do love the topic he's gonna present about. I'm totally into what he's preaching there. Hopefully everybody of you has read the book. For those single one of you who have not read the book, there will be some books given out later, so if you did not get to that, you can do it later. I believe you will introduce yourself, so I will just hand over to Vaughn, and a big welcome for him, please.
Thank you. So, yeah, well, I'm Vaughn, and how Christian and I know each other is when he was at Auto Scout. They engaged me to teach a workshop there in Munich, and I also did a few days of consulting or something there, and I was, one of the happiest moments was when I saw one of the, I think, product owners or architects was tweeting later something about that they had actually moved forward with the DDD based service that they had been working on. I think it was the garage, how you say garage, instead of garage, as we would say in the US, the garage service for Auto Scout. And yeah, so I was very happy that worked out, and they were using domain-driven design, and they had used event storming, which I had also taught, so that was a great opportunity, and so it's good to be with Christian again and all of you, so thanks for attending. So this is a little bit maybe an odd expression to read if you're not a native English speaker. What does it mean? Well, reactive DDD, first of all, reactive software development has become a real thing these days. And your interpretation or the way that you use reactive may be different, but basically what it means is you have a message-driven sort of architecture, and any objects that any objects that do anything inside the system are not doing something because they are in control. They're doing something because they've been told that something else happened. Something else happened, or we want something to happen, and so the object will react to that. Actually, this talk has nothing to do with React.js. Is that okay with you? So what I'm talking about is sort of this, the server side or the business model and reactive within that. And then, concurrent, well, we all know what concurrent is, but waxes Fluent, come on, what does that mean? Well, in English, at least in US English, waxes means, well, like you wax a car, you make the car shiny, you make it noticeable, you make it look good. And so while we all probably are into the technology side of things in being reactive or developing reactive software, and we like the concurrency or the parallelism, what about the business side of the equation? So interestingly, I had a professor from one of the German universities in my workshop this week, and I asked him if he had ever tried to teach domain-driven design in the university. And he said, you know, the students really don't want to learn it. They're just interested in technology. They just really want to, you know, play with new tools and new languages and new frameworks and so forth. And you know, I mean, to me, that's quite disappointing because we're all working for businesses, aren't we? And playing with new tools and everything might be fun, but if we aren't adding value to the business, then all that playing does no one any good, and it's quite costly, really. And so, you know, what I want to emphasize in this is that a Fluent interface to a framework and a Fluent interface to your business model is at least as important as the performance, the concurrency, the ability to you know, keep all your cores at 100% or near 100% usage at all times. So that's quite a bit what this talk is about. You know, you probably know me for my my DDD books and so forth, but I've also started this open source platform named Lingo. It's the Lingo platform, and so I'm the chief architect of that, and I have some contributors around the globe. We have several developers in the Barcelona area, a few developers in Germany, a few contributors in Germany, and one in Paris, one in Australia, a few in the United States, I think 3 of us total in the US. And we're trying to build a team, but we're roughly at about 15 contributors to the Java platform, and we're also developing the Lingo platform for .NET. So, yeah, it's quite exciting, but if you're unaware of that, that's actually a large part of my topic tonight is talking about the advantages of using tools to accomplish the use of domain-driven design. So I think it's fair to sort of set the stage by saying that you know, we have a sort of a certain situation that we're in right now with our industry of software development, and I think probably if I show this image, you could probably relate to this. This is, you know, what is BBOM? Well, it stands for Big Ball of Mud. And probably most software systems work like, you know, exist like this. This is where actually you couldn't point out in this big ball of mud where there is a particular model, where you're modeling an aspect of the business, because there are probably at least several models, you know, could be a half a dozen models or more that are actually in this big ball of mud, because you're trying to do, most likely, not you, of course, but anyone who's created this has tried to do too much in it. They kind of see the world as, well, we have to accomplish this, we have to do this, so let's just keep piling concepts into this model. And so it could be that there are actually, you know, maybe 5, maybe a half a dozen implicit models here. Now go try to actually point out where the specific concepts are for each model that's in this big ball of mud, and you would have a difficult time doing that completely, because some of these objects in here share concepts across models, and you know, we just haven't given a lot of thought to what it would result in if we tried to separate those models. Okay, so that's one place where we are. Another place where we are is a lot of inefficient software. So this is mostly today because of blocking, the blocking paradigm that we've all sort of grown up with. And ever since we've learned programming, we understand that I make a function call or a procedure call or a method invocation or whatever you want to describe this as, and the software, the client software that's invoking a service on the server is a blocking invocation, let's say, or a blocking request. Now, I just want to point out that when I say that there's a client and a server, a lot of times our mind goes to a client-server, remote invocation, maybe like SOAP or an RPC. That's not what I'm describing here. A client is just a client object. So just say it's an object in Java or C# or Ruby, whatever. Choose your OO language, and you have a client object, and you have a server object over here, and I invoke a method on the server object. What happens to the client? It blocks until the server completes its work, and then it gets control back. And we feel quite comfortable with that. It makes us, it protects us from having to deal with the cognitive dissonance of what may be happening to me if I don't block for this situation, right? So, but at the same time, any time that your software blocks, it means that your thread is busy doing things like waiting, and generally the blocking happens at I/O, or waiting for some other kind of response. Maybe you make a REST request or a SOAP procedure call across a boundary, across a process boundary, and you're gonna, this server looks like it's local, but behind this is actually, an implementation that hits the network and makes a request, and that can block, right? So this is pretty much what we're living with today. And the blocking, yes, is in the behavior, but like I said, it's in the HTTP request response. It's in I/O, obviously the database. And there are some solutions now that are starting to arrive where you have non-blocking HTTP request response, and you have non-blocking database drivers, database interfaces. So we're getting ahead on this, but they're still not as prevalent as they should be because, well, a lot of us are working with software that is decades old, and it was just never designed to work this way. And even a lot of brand new software is just maybe it just seems too complex to try to implement a non-blocking software design. So, and then we also have this situation where we tend to develop anemic domain models. And I just want to say something that I find the term anemic domain model kind of, an oxymoron, because it's not a domain model at all. So it's sort of almost like, wow, we're really complimenting this software by even including the words domain and model, in the description of it. So it's really not a domain model at all, and this is what I mean by that. Say we have this client class here, and this client is annotated. This is a Java class, right? It's annotated as an entity, and of course this could be a C# class as well. Instead of the at entity, it would have square brackets entity, and that would be called an attribute. And then any of those annotations that are marking fields in this client class, describes basically what? What is this? it's not even really an object. It's a row in a database, right? And we're just simply using general purpose programming language. I'm not sure. Is it a convenience so that we don't just write transaction scripts and just insert and update data directly into the database? We come up with these crazy complex architectures, and all that we're really doing is putting lipstick on a database table most of the time. And I really don't understand why we go to the trouble of doing this, because again, it's just really expensive for companies to pay for this. And we get to call ourselves architects, but man, this is not architecture at all. This is just, SQL, SQL, if you will. Yeah, so, this entity is, or this client is annotated as an entity. We have an ID, and then everything else is a column. And so what do? We just sort of poke data into this object. We persist it to the database, and then we read data back out of the database into this, and this becomes sort of like a convenient transport between the database and our application. And then what I find is this, right? We've got inarticulate software everywhere. So this is an example of Microsoft explaining how to use an actor model called Orleans. And the very typical, sort of documentation for Orleans says, name your game object iGame grain. First of all, do you know what a grain is? A grain is sort of an actor to Orleans, but it's just this sort of distributed object kind of thing that floats out there. And I have fullest respect for the work that's gone into Orleans. It's a magnificent product. They're just teaching people how to use it and name their objects in the wrong way. So they've made a marvelous product, but they say name this iGame grain. I had a discussion on Twitter the other day about this, and I said, well, how is this actually helping the industry write better software? The actual framework, the tooling, naming is leaking into our domain model, just 100%. We don't have a game. We have an iGame grain, and what an abomination, really. I have to say, you may be a .NET developer, and you may be okay with this, but this is really, truly an abomination. What it means is, this is an interface. And so what you want, what is it? What are we accomplishing by this? We want like our client to know that they're using an interface. Why do we want them to know that? Like, is that a good idea to say, hey client, by the way, you're using an interface? Why? Like, why wouldn't we just want to call this game? And we might call game, the implementation of game, anything we want, but please not game impl. Don't do that. So choose a good name for your game, or don't give it an interface at all. Just make it a class that implements the only interface that it has, right? But in this case, I think Orleans wants you to use interfaces. So maybe you could come up with a useful name for the interface, like game, and maybe you could come up with a useful name for the implementation class, like, I don't know, something else, but not grain and not impl. I'm thinking that's a bad idea. Now, move down to this next inarticulate example. And of course, since we have a game grain that we're now using, of course, what we want to get from the game grain is the player grains, right? Isn't that how you talk when you play a game, right? Hey, let me get some other player grains together and we'll play a game grain, right? I mean, sure, that's how we talk all the time. And then, so we've got this player grains, and we're going to use the game grain to do what? We're going to get players async. Isn't that a great idea? Get players async. There's actually only one useful word in there. It's players. That's really what you want is players, isn't it? You want to get them? Like, what does get accomplish in this? I mean, we don't take any parameters, and we know that we have a return value of some kind. And wouldn't it be great if we just got like a collection of players? You know, player instances. That would be pretty cool. And then, of course, you know, go clear out to the end of this declaration of what kind of data we're exchanging, and we have a task there. Do you know what the definition of task is? A task is something that has generally multiple steps that must be carried out to completion. And so you start out with the definition of a task, you perform these different steps, and then that task is completed. But this is not a task at all. It's just something that people in Microsoft decided to call, you know, name the concept that really means something will happen eventually here. And we'll have an answer eventually. So they decided to call it a task. And so look at what we have here. We have a task list of player grains, and we're going to use a game grain to get players async. Now, put any business person in the world in front of this and say, you know, like, doesn't this sound good to you? Isn't this how we would like to implement a game for the whole world to play? And I think most business people say, you know, I won't even tell you what they're going to say. So, you know, I mean, really, think about what we're doing here. The async keyword is not so bad. It's really just sort of tucked away on the implementation. We don't really see it on the outside, so that's okay. But couldn't we just pick better names than this? Game? Wouldn't game be good and players be good? And just when you want to get players, you just say players and you get players back. That would be pretty cool. You might even want to name tasks something like completes, or I think future's a pretty good name. But anyway, we'll go into that. Maybe I spent too much time there. So this is where I think we need to go. So we've spent plenty of time playing with tools, plenty of time playing with technology. Could we just maybe do something for the business for a change? So I think where we need to go is break up the monolith, right? And notice my objects here that I'm drawing now are circles instead of squares, and that's just the way that I choose to draw actors. Things that are, they're still objects really, but they're kind of a little specialized object in that they still hold state, they still receive method invocations, but the method invocations that they receive are performed asynchronously. So when someone says for this entity to do something, it doesn't immediately do it. Instead, a message is sent to it asynchronously, and eventually that entity will do what you ask it to do. So I draw these entities and these resource handlers. So we would probably refer to these as REST endpoints, but they're resource handlers. They receive requests, and they're all operating asynchronously. And everything that you see here is operating asynchronously. But maybe we just have some simple objects here that are used to transport data up to the user interface. But everything else is operating completely asynchronously. And notice, right, we've got this very small kind of boundary and just a few concepts in this, because this probably constitutes the concepts that are related to a specific aspect of the business and nothing more. So we purposely try to constrain what we call language, our ubiquitous language. But when we hear ubiquitous, I think some people say, wow, ubiquitous, I got to get all of the corporation using this language. That's not what ubiquitous means. It means ubiquitous within the team. So the team speaks this language, they help each other develop it, they talk about it, they draw whiteboard diagrams and make points about things on the whiteboard, and they render this language into the model. It's ubiquitous in that sense. They do, they're using a language throughout this solution. Okay? Another place that I think we really need to go is, well, I already showed you those circles are actors, and this sender, by the way, and this receiver could, we could just substitute the previous client server here. That's what that is, and notice this little symbol here means that I'm sending in a message. It could be that this message is an object, but it doesn't have to start out being an object. The message is actually, the sender is actually making a method invocation on an object, but behind that invocation, the method invocation is reified into actually a message object. May just be a lambda, right? A function, a function object that's eventually passed to the receiver, or in essence, it eventually has an invocation on the receiver, and the receiver actually gets a Typesafe method invocation asynchronously. No special keywords. It just works, right? And event-driven is quite important with reactive. Because you have smaller bounded contexts, smaller services, not these big balls of mud, things are going to tend to happen across subsystem boundaries. So you've got these sort of subdomains or subsystems that are being used together to accomplish a complete goal. But because they're smallish, and other services need to know what happened in one service, we're going to send events. Well, how do those events come to be? So here, notice we've got this controller actor. Could be a REST endpoint. It could be one of those resource handlers that I pointed out before. But it could be just more like a UI controller. It doesn't matter. It's asynchronous. It receives a REST request, let's say, and all that it has to do is dispatch the REST request to a domain model object. And it does it asynchronously. Take out all that architecture mumbo jumbo, 4, 6 layers or whatever. You don't need them. And look at what you get, right? You get asynchrony everywhere. The controller doesn't block a thread while it's waiting for the aggregate to perform. The aggregate gets event-based persistence for free, and that's asynchronous. So and then the aggregate, eventually is done, and nothing's blocking here, and eventually the controller says, oh, okay, that happened, and we can now safely produce a response. It could be that the client is actually blocking, but nothing on the server side is blocking. Nothing within the service is blocking. Now, I'm not suggesting that your client should block. I'm just saying that it may, but it doesn't have to, because there's also the client side, HTTP interface that is non-blocking. And finally, whenever this side finishes, that side will find out. It's all reactive, right? Everything in this, every actor, every concept along the way is just reacting, saying, okay, oh, this is ready now? Okay, I'll do something with that. Oh, that's ready now? Okay, we'll do something with that, right? So that's sort of the whole idea here. Oh, and notice too that controller is sending a command to an aggregate. An aggregate is just a special entity typed in DDD, and this command is sent. But notice this aggregate or actor, right, still already has some commands sort of queued up for it. So this is called the mailbox of the actor. And this command will actually not be invoked directly on the aggregate. Instead, it will go into the mailbox. And this actor is only handling one message at a time. And that means you don't have to worry about race conditions or volatility within your actor. There's no blocking. There's no locking anywhere. Not even the message, in queuing into the mailbox is blocking. Nothing blocks at all. and there's no locks, and you never have to worry about, you know, two clients or two controllers accessing this instance simultaneously. Okay. Okay, so that's pretty important. Oh yeah, I got to show you my broken coffee mug. This is from about the year, I can't remember for sure, I think it was like 1985 or 1986. And I know I'm dating myself here, but, you know, so have you ever heard of OS2? A few of you have.
I used it already.
Yeah, you used it, yeah. Actually, OS2 was pretty cool. It was a great sort of mission-critical operating system. There was messaging built in, and actually at one time, Microsoft and IBM were working on this together. Microsoft had their sort of chief architect or lead architect of OS2, Gordon Letwin, and he wrote a book on Inside OS2, and Microsoft asked me to write a book on OS2 way back then. And so I got this early build of OS2, Alpha 700 something, and boy, you know, I mean, as most Alpha OSs are, it was pretty, you know, rough to use. But you know, I got to see this OS2 operating system grow up. It was originally codenamed 286-DOS. Okay, when I got it, it was called 286-DOS, and I got a, you know, stack of diskettes, 5 1/4 inch diskettes like this, and you install them on a 386 machine. Okay, so why am I showing you this? Well, this was actually my first, you know, sort of era of using messaging. There were message queues built in to OS2 at the operating system level. There was all kinds of concurrency. Threads were introduced. I don't know if OS2 was actually the original thread definition, but this was pretty new stuff, right? And OS2 was at least really making it public, right? And then somewhere along the way, Microsoft and IBM got mad at each other and decided they didn't want to work with each other anymore. And Microsoft said, oh, by the way, Vaughn, thanks for writing that, you know, 15-chapter book that's like 500 pages, but we're not going to publish it. And so, yeah, but I got this coffee mug. The other really cool experience that I got, I don't know if any of you have ever had this chance to do this before, but have any of you ever scared Bill Gates before? So one of the main example that I implemented for the book was a reactive message-driven desktop. And it was character mode. It was not graphical mode like the sort of Windows 1 or Windows 2 was. And you know, of course, eventually OS2 was going to deliver what was called then the presentation manager, was the graphical desktop. But I said, why wait for that when you could just use a graphical mode, I mean a text mode desktop that worked, you know, with memory mapping and really fast desktop, and every application as a separate exe could just attach to the desktop, and you could move things around with the mouse. Everything that you could do with, you know, Windows that actually wasn't multitasking, but this was. And you know, of course, Bill Gates was reading everything and looking at everything back then, and he said, shut this down. That was actually the directive. We don't want this in a book because it's going to compete with Presentation Manager. Well, it wasn't long after that they just decided not to do OS2 at all anymore, and the book never got published, but I, you know, got a lot of great experience with messaging back then. Okay, so today you might be able to use reactive, but are you preserving your language investment? Is your best choice of doing reactive development a language that your organization has already invested a lot in? Does that, you know, framework or tooling that you have to do reactive, does it actually promote model fluency, or does it teach you to, you know, write really technical software that, you know, business people can't comprehend? Is it type safe? along with language investment, do you really have a type-safe solution, as in, I'm confident that when I invoke this method that the types that I'm passing to it are checked by the compiler. I mean, if you have a type-safe language, you may as well have type-safe tooling around it too, right? And then testability. So, and believe it or not, a good number of the reactive options that you have out there in the market today fail in one or more of these categories. Okay, so let's say that we are going to accomplish reactive DDD. This means that we're going to have multiple bounded contexts, and the user may be using either any one of these contexts or any number of them simultaneously through the user interface. But wouldn't it be great? First of all, let me explain what Fluent means. Okay, from an API perspective, instead of naming something that completes in the future a task, wouldn't it be neat if it was just, if we said that it completes, and it completes with some type. This happens to be a .NET, version of the interface, but just lowercase the first, word in each of the, and it's Java, right? So, yeah, so completes, then imagine you're the service, right? You are the actor that's performing a service, and you need to return a value, and what do you say? You say, completes with my value. Doesn't that make you want to weep? I mean, it's just beautiful. It reads just like what you want to do. And in the client, look on the other side, right? We have and then to, and then consume. And I'll show you how that would be used. Oh, by the way, yeah, I just wanted to say, is complete a noun? It is in the year 2019. Right? So I should have, actually someone suggested I should have named it completely. And then, or completes, what? Something else. Yeah, so, no, it's really more important to me that something is fluent. So, okay, now we have a concept called a protocol, and a protocol is an interface, but I like the word protocol, but it's because it says, my component provides this protocol to my clients, right? And one of the protocol interfaces that we have for proposal is that I can submit a proposal. And notice how this would read in actual language. And you'll see it in a bit, but it's proposal dot submit for client expectations. I want to cry. It's so beautiful. Proposal deny pricing with a suggested price. Proposal verify pricing. It's fluent, right? It just reads the way that we would have conversations with business people. Proposal submit for client expectations. And you might be wondering, man, does this say, maybe this is Kotlin because there are no semicolons? Right? Actually, no. I just hit enter 20 times, so the semicolon's way down here. Okay, so here's the client side of that asynchronous, sort of message sent interface. So here, I want to start from this side and just kind of make a point here. So we have this concept known as a stage. A stage is where actors play, right? Isn't that where actors play? So we have a stage, and then we ask the stage for an actor of an address, and this is the protocol that we want back from the stage. That's an asynchronous message that's being sent to the stage. Okay? And that means that this next expression in the pipeline won't be executed until that asynchronous expression ends. So you maybe were thinking to yourself, how in the world do you deal with asynchrony when all these things are happening? How do you actually sequence anything in this? Well, it's simple. You just say, I want this, and that's happening asynchronously, and then, you know, once you've finished with doing what I asked for there, and then two, and then two says that the proposal that was returned asynchronously is actually going to be another asynchronous message send. So we're going to say proposal verify pricing. That's asynchronous because that's going to an actor. And then notice that this otherwise is here because just in case the stage didn't find that actor, we're going to respond. This happens to be in a REST endpoint, right? One of those resource handlers. And we're going to respond with a response of not found, right? So doesn't that read just sort of like we talk? So that's the otherwise in case this didn't work. And then, right, when this completes, and then proposal, so we get the proposal that we originally had up here that we sent a message to, and the outcome of that, and we're going to serialize that proposal and then consume it by basically taking the serialized representation of that proposal, and we're going to create a response of okay with that serialized object. Okay, so that's just, you know, and all this is happening completely asynchronously, but you don't have to worry about losing your place or trying to figure out when this finishes, how do I do the next thing or anything. It's all taken care of for you. This is actually also a little bit low level. We don't actually require you to go that low level, but it just shows you the expressiveness of it. Yeah, so here's inside the proposal entity itself. Notice that the proposal entity, right, implements the proposal protocol, but it's also an event-sourced entity. It's event-sourced. This, again, this is C#, but you know, if it were Java, it would just be extends here and implements here, right? And so inside the proposal entity, when it receives the submit for method, it just applies a proposal submitted event with, you know, whatever parameters we want that proposal submitted event to be persisted with. And this persistence, the persistence happens behind here, but you don't even have to know that persistence is happening. The persistence happens asynchronously, and this entire interface, actually, before any of that happens at all, the thread that's running this, right, handling this request or delivering this submit for message falls off the end. So that doesn't even really complete. So we free up the thread that was doing that, and that thread's now being used for something completely different. And you know, so, but the thing is, you don't have to think about any of that. It just all works for you. Is this reactive? Yes. Well, I just kind of showed you how that works, but it's Fluent, right? So we're really close to what the business thinks and the way they speak. Is it type safe? Yes. So we might just spell this out longhand, proposal submit for client from client ID, expectations of a summary, a description, keywords, completed by step, you know. So it's all type safe, but it's also completely fluent. So now the thing that happens with so much asynchrony, concurrency, parallelism, is the fact that we also introduce uncertainty. And I have to say that when the uncertainty is introduced, people come up with some pretty, I don't know, complex ways to try to solve that problem. Essentially what happens with when uncertainty gets introduced is developers generally try to make it certain, right? They just say, well, let's make it feel like it's blocking. Let's make it feel like it's fully sequential. And that's really hard to do, right? Because it's not. So, you know, we'll use patterns like from the Enterprise Integration Patterns book, not that anyone from Munich was ever involved in that. But yeah, the deduplicator and the resequencer, I mean, they're okay, but you really don't need that, right? And I'll show you why. So, yeah, you have uncertainty because of all the message sending and everything going around across various bounded contexts. So what do you do about that? Well, if you read a paper by Pat Helland, and I referenced this paper in my red book, the name of the paper is Life Beyond Distributed Transactions. And what happened is, right, Pat Helland was hired by Amazon, you know, I don't know, what is it, a couple decades ago maybe? And Pat Helland was, you know, had implemented XA drivers, global transaction managers, for really serious, you know, distributed transactions for a company. I think it was Tandem Computer, at least that was one of them. And so, you know, Pat Helland was rather known for his expertise in global transactions. But when Pat Helland joined Amazon, and he tried using global transactions at Amazon scale, and Amazon really, when you think about it, 20 years ago, I mean, I remember seeing Jeff Bezos on some morning show in the US, and it's like, you know, you just kind of like, this guy's really selling books, you know. And so you're not quite sure how this is going to work out. So you don't expect Amazon, you know, scale to be really enormous 20 years ago, or maybe even more than 20 years ago. But even then, Pat Helland just said, it doesn't scale. So way back when they were nowhere near the scale that they face today, and performance, you know, situations, Pat Helland said it doesn't scale. So what he did is he said, okay, everything has to be eventually consistent. And he sort of maps out in this paper some ideas about how that should work. There's an update, right? There was this old PDF that you could download, but now there's an updated version of this article or paper on the ACM. So I think you can go to acm.org, and you can get this paper called, you know, anyway, go there, Life Beyond Distributed Transactions. And but the point is that Pat Helland makes in that paper, he says, when you cannot count on global transactions, uncertainty must be modeled in the business logic. Okay? Now, here's the thing, right? Pat Helland is a seriously smart dude, and he has worked in some seriously, you know, high performance, high scale environments. So don't believe a word I'm saying. Believe everything he says, but just trust me. I'll show you how to do what Pat Helland said. Okay, so we've got this internal, you know, implementation of proposal entity. Okay, this one's in Java. So we extend, right? We extend event source and we implement proposal. Same thing, really. So we have a client and we have expectations, and of course we have an identity, a unique identity for this proposal entity. Okay, but how are we going to model uncertainty here? So we add this concept here called progress. And progress, actually all of these concepts within proposal right now are value objects. They're immutable. And, you know, they're very functional sort of based, which means you don't have to worry about mutating state and so forth. You do have to, you know, there is mutating state here, because we will replace these value objects when something changes, like we'll replace the progress when we make a further progress in this sort of mini process that's going on. But now you may not think of a progress as actually being part of a proposal, but that's why we don't create real world models. We create useful models. So a useful model says, right, I have a proposal, but we need to know what's happened with that proposal? Has it been submitted yet? Has the proposal been submitted by the client? Has pricing been verified or rejected? Have we found workers to work on this proposal, this proposed job task? And notice I had to use the word task, right? That's actually a business term here, not a technical one. So, and then, right, and have we found that the schedule is open for certain workers, right? Do they have an available schedule to work on this? So these are just some of the steps that the process or the progress will go through, which is actually also a process. And you know, the thing is, like, we might wonder, so which of those things will happen first? When will it happen? Will they happen in the sequence that we expect? Will it happen multiple times? You know what? We don't care. We literally don't care, because we're modeling this at the heart of the software, not out at the edge, and we don't have to figure out any hard stuff. We just simply let it all happen, and we let the progress tell us what we've already seen. So for example, this progress, when that proposal dispatches and says verified for pricing, we're going to, you know, return a brand new progress instance, because this is a value, it's immutable, right? Nothing in here can be mutated. And we're going to return a new progress, and that new progress is now going to say that pricing was verified, okay? Okay, so, and one thing I want to say is, so if we go back here, right, and we're looking at the proposal again, whenever the proposal needs to know, has pricing already been verified, we just simply ask the progress, has it already been verified? If so, I'm going to ignore this current stimulus because we don't need it. You know, it's already happened. But if it hasn't, then we advance the progress. What order should things happen in? We don't care. It's when they're all done that we can do something, right? We just say, we're hanging out till all these things finish. Whenever they finish, we'll do something about it, right? I mean, isn't that way easier than like trying to figure out how long should we keep these previously seen messages around in case we see it again, so that we know that we've already seen it? What if I delete that now, but maybe what if the message mechanism sends it again tomorrow, right? That we're just, man, we're making things so complex. And you know what I want you to be with this is completely underwhelmed. I want you to go like, gosh, that's boring. Yeah, it is. And that's how most software should be written. If you're really thinking about how to solve hard problems, do it the easiest way possible, not the hardest way, right? So I'm just taking, you know, I've just taken advice from smart people and said, okay, well, here's how you would do that. Okay, so now, right, everybody's going microservices. We're at the Microservices Meetup in Munich, and so we want to go microservices too, right? So, but let me ask you, what does that mean? Because you want to go microservices, what's the size of a microservice? I know. If you attended a couple years ago when I was here, you heard me talk about this before, and I'm going to talk about it again, because I never get tired of this. Yeah, so now I just have to say, right, when you're working for a business, like the business that owns or pays for the building where we're sitting right now, paid for the pizza and the beer and all that stuff, and lots of salaries, this is what they want in result, right? They're like, this is what we want. But you know what your job is? Here's your job. Convince them that what they really want is this. That's the microservices of piles of money right there. Right? So that's your goal. And let's get some further definitions. So actually this is legacy. So that big ball of mud, you know why it's legacy? Because it makes money. If it didn't make money, you know what it would be? unplugged, right? It would be unplugged. So, okay, it's a mess, it's horrible, we hate it, nobody wants to work on it, but the company loves it because of that, right? Now, I just want to say something. I think that the name monolith has gotten a lot of bad press. Because this is actually a monolith. You could do way worse than this, right? And I've already showed you that you could do way worse with that than that. So this is a well-modularized monolith. Okay, we have a few, objects that are too big here, and overlapping responsibilities, and it's not perfect, but wow, look, we have this sort of clean separation, loose coupling between services, and whew, isn't that nice? I mean, you could actually call this an architecture. And so, please, stop giving monoliths such a bad name. Big ball of mud is, yes?
Yeah. There's a famous German architect, and he says to this architecture, modulith.
Oh, okay.
So he modulith, because it's modularized, and so it doesn't
okay,
have this
module lift.
Yeah,
not
module.
I thought he was calling it module. I like that. Yeah, good. I like it. Okay. Can I tweet that later? Okay, so, yeah, you could do a lot worse than that. Yeah, this is what you could do instead, right? Okay, here we go. You're going to love this. If you heard it a few years ago, you're going to hear it again. What is a microservice? Is it 100 lines of code? Why not? I mean,
can be.
Seriously, like if the person who said they invented microservices was here, they'd probably be telling you that it's 100 lines of code. That's okay with me, right? I mean, they invented it. It's just that, maybe it's 400 lines or 1,000 lines or whatever. And so I just want to show you my representation of what I think a 100 lines of code microservice results in. And you're thinking, oh, this is unfair. I'm using Kafka, so that makes everything wonderful. And then you're thinking, but Vaughn here, he's drawn these little balls of mud. But man, they're 100 lines of code. How could that be? Okay, so we got like 30 microservices going here, and that's okay. Actually, most people that I've heard that succeed with this kind of microservice are dealing in a few tens of microservices. But I spoke to someone in the past few days who said, we've got 50 of these and they're driving me nuts, And then you think to yourself, what do we do about these dependencies anyway? I mean, what if we just decided to unplug this one right here? What would happen? Catastrophic failure? Or would it be okay? Do you have any idea? I mean, how would you know, even at this point? Maybe you could figure it out. Maybe you've seen that it hasn't received any messages for the past 24 hours. Let's unplug it. Sure about that? Are we running a sales campaign? In German it's action, right? Action. I learned that yesterday. So this is an action campaign microservice. Can we unplug it? No. We got it figured out, right? Let's not unplug it. I got this. It only costs $400 a month to keep that microservice working. Let's just keep it working. It's only $400 a month, right? Right. Yeah, so let's just keep that thing running. These little balls of mud, they might be clean little, nice little nuggets of implementation, but all together they are a distributed big ball of mud, right? You have no idea what anything is doing. You just keep pushing stuff out there and hoping that you don't unplug something that's going to cause catastrophic failure. And, you know, there's this to think about. And I just have to say something. Who, you know, like, my guess is this company, Vaughn, do you have any 2 million line systems?
No.
Yeah, come on, of course, huh?
I don't know.
Yeah, 5 million? I mean, I've worked at 2 million line systems, right? Right? 5 million line systems? You know what that amounts to in 100 line microservices? Right? 20,000 microservices. Multiplied by $400 a month is $8 million a month to keep those microservices working. That's a 2 million line of code system. Per year, $96 million. 5 million lines of code? 50,000 microservices. $400 a month, that's $20 million a month, $240 million a year. Now, I've never met your CIO, but that person is going to fire you if you do that, right? That's just not going to go well. Besides the fact that nobody knows what's going on with it. So, okay, that's my rant. I'll move on to more productive things. And so this is what we want to shoot for, right? And I just want to say something. So that little 100-line microservice, maybe it's a function as a service. I did talk to someone last week who said, how should I implement this? I've got like this calculation that we use across 3 different bounded contexts, and I can't figure out where to put it because all 3 bounded contexts use the exact same calculation. And I asked a few questions. Well, is there sort of one place where those calculations happen more than the others, and does it sort of, you know, does the need for the calculation initiate somewhere? No, not really. They just kind of all use it. And I said, well, that seems to me like a perfect place to put a function. You know, just let all 3 bounded contexts call that 100-line function. And if you only have one of them and it does the job, isn't that like something to celebrate? I think so, right? So you don't have to have 100-line functions everywhere just because, you know, AWS supports them now or Azure supports them now. You just don't have to. So this is what we really need to be focused on. Instead of those silly, you know, what's the size of microservice and shouldn't I be implementing everything as function as a service? Instead, I saw this some time ago and it just resonated with me, and it says, you know what the problem is in our industry? We just always stop short of the really strategic advantage in our software. We're just doing the common, ordinary business process modeling, and we're okay with that because, I don't know, maybe we're more interested in technology than we are in the business. So really look for the strategic drivers, right? Tell objects what to do. Don't ask objects for data. Make some decision and set data back on them, which is what anemic, objects do, or what you do with anemic objects. Instead, tell objects what to do. When you do that, your code becomes explicit and testable. Now, go back to that anemic model and not even a model, but those anemic classes and objects. And just imagine that there are 25 or 30 fields in there, and some of those fields actually belong together, right? Probably if you sort of brought all the whole concepts together, those 25 or 30 fields would be reduced down to 4 or 5 value objects or something like that. But think about trying to write a test for those anemic objects. How many permutations are there to setting 25 or 30 fields incorrectly? How many ways do you have to test that to make sure it's actually impossible? You know, you can predict that these are the ways that I hope that clients use this object, and I hope that they set this data together, and if they do set this data together, it tests okay, but you actually can never be sure with that. But in this case, when I have a client that knows how to relocate to a postal address, and I simply mutate my state with a new postal address, and I emit an event that says client relocated, I can test that. If I write 2 test case methods, I'm fully tested, right, for that behavior. So, you know, if even if for no other reason, testing your code is a great reason to be explicit when you model. Okay, now remember that modulith before? What if all those were bounded contexts, right? That's why I'm saying you could do way worse than, you know, than a modulith or a monolith, because, yeah, you know, and we can actually go in and refactor stuff because we have tests that prove that what we have currently works, and if we break a test, we know why we've broken it, we can tell why we broke it, we can, you know, either fix the test or fix the code that broke the test. And look, we've got this loose coupling everywhere. And you know what this does for you? If you decide that you want to go to microservices later, and that's pretty easy to accomplish, right? So if you're talking threads between these two, maybe you have multiple threads doing messaging between them, now you just introduce the network. I mean, I don't want to take it too lightly and say you just, but, you know, and probably even if you're using one database schema or one database here, probably each of these have a well-defined table. I'm just guessing they do, right? So you could probably take any one of these and just break it out as a microservice one by one, and take those tables with it and start talking one by one over the network to just one of those. And I'm going to guess that that's going to work out really well for you. But if this is what you've got, right? Now, I'm not saying that it would never work out, but I don't think you just go here. Now, I have to say that actually most clients who contact me and say, Vaughn, could you teach us how to use DDD, and could you help us get out of the big ball of mud? You know, the problem is, they don't have one of those. They got like 1,000 of them. You know what I'm saying? I mean, seriously. You want to talk about 2 million lines of code or 5 million lines of code, you know, and they're desperate to get out of that. You know why? Because they can't even make 1 or 2 releases a year. How can you be competitive today when software teams are regularly introducing releases 5 times a day, right? Or more, maybe hourly. You can't compete against that forever. It's only your bank account that's keeping you, you know, protected from that competition, and that will run out before, you know, it might take 10 or 15 years, but it's going to run out. So how do you get there from here? Okay, first of all, I just want to make a comment about COBOL. If, you know, so sometimes I say, don't necessarily rewrite, but if you got this, rewrite. And here's why. Because most of the people who wrote that code have great-grandchildren now. Right? And you really, it's hard to hire people to keep that stuff working, so just really get out of it. Otherwise, you know, if this is now a big ball of mud legacy system, and believe it or not, yep, they're written in Java and C# and Ruby on Rails and all that stuff, right? And if you need to get from here to here, I really think you need to go here first. So what you're going to do is you're going to clean up the monolith just like you would eat an elephant, one bite at a time. You know? I mean, you can't just sit down and take a few big gulps and the elephant is gone. It's just going to take a while. How do you do it? You make this effort from here to here change-driven. The organization has to say, we need a change to this software. And we want the change to this software to work, you know, we need this specific thing, and then what you're doing is adding value to this software, and one byte at a time, you're modularizing it. You're cleaning it up, and you're making it test-driven. So you have a business reason to be in that code. If you ask the business for 3 months to get from there to there, I'm almost certain you're going to fail. Well, you may not entirely fail in that you may produce some good results here, but you're not going to be completed, right? You just won't. So you're going to have to chip away at it, one byte at a time. But, once you do that, you can leverage these other approaches. Now, what I'm going to do is use event-driven now to show how you could maybe do this a little bit different way. And I have done this, and it's difficult, okay? So what you do is you've got this big ball of mud monolith, and there's almost no way to tell exactly what changes at any given time. So the UI, the user makes a request, and all this stuff happens all over the place. But one thing that the sort of central point that you have is you have the database, and the database sort of knows, right, when I insert a row or update a row or delete a row, I know that happens, and we can know that it happens if we put triggers in those tables. Now, I know you're saying, seriously? Well, I'm going to show you probably a better way, but it works, right? So here's what you do. You have a trigger. It says, okay, this row updated. The trigger is used to generate an event that says this happened. Now, I'm not suggesting that this is the way that you should model domain events or produce domain events in the right way. This is what you do when you're in this situation. So you trigger, you see a trigger, you create an event, and you put it on a topic, and this one little microservice that you're using to start, the strangulation process of this big ball of mud sees that event, and it does something here, right? And as we get value in this little microservice bounded context, we start pointing the user interface over here little by little. And what happens though is when the user makes a change here and we create or update or delete something here, what has to happen? This has to know, because most of the UI is still working this way. So this has to put an event on a topic, and that topic has to be, subscribed to by the big ball of mud, and now we make an update into the database here, right? So that's a compensating transaction on both sides, right? Because we want to keep the data sort of as closely in sync as we can. Now, I just want to make something clear. When the event flows this way into the topic and in here, and an event gets emitted back out here because of that, you want to make sure that you ignore that specific event here, or you will have one of the most interesting Stack Overflows you've ever seen. Okay. All right. Okay, but you're thinking, come on, triggers? Seriously? Well, there are two products. One is open source, the Debian. Maybe you've heard of it. I think some folks in Europe have been working on it. And the Debian is basically a commit log reader, right? Or basically a way to see the activity that happens in the database's commit log. So instead of creating triggers, you simply read the commit log as each commit happens, and you generated an event from that. And really, it's the same pattern as I showed before. It's just that you're not using triggers. You're seeing officially, right, the database will make this change, and I can know about it, and I can signal that over here. So it's really the same thing. And if you're using Oracle database, you can get the same kind of product for Oracle using Oracle Golden Gate. Debezium currently supports MySQL or MySQL, Postgres, and partly, I think they're pretty good with Microsoft SQL Server, and I don't really know how to say those. And then it has partial implementation for Oracle, but if you really need to get out of a monolith with Oracle, your company's probably going to help you buy Oracle Golden Gate to get that right away. So once you have this thing in place, there are actually different ways to strangle. This is another way to strangle, or restructure at least. So the entities that currently exist in this monolith, use them for write only. And as you update these for write, you're never again going to read these entities to try to produce data for the UI. Instead, what you're going to do is generate a query model. And you're going to take the hit in the UI. And the reason that I say this is because I have conversations, again, with very, very large, successful, very wealthy companies. And even though actually some of them are still running in COBOL, they've rewritten the UI like 5 times in the last 10 years, anywhere from Flex to, you name it, like, right, every 2 years they're re-implementing the UI. Is it a big deal to take the hit in the UI one more time? And there is some eventual consistency here, right? But again, there are ways of solving that problem. We have WebSockets now. We have, server-sent events, which are similar to WebSockets, but, in other words, we can solve these problems. And then once you sort of get that all divided up, you're probably going to have a better understanding of, which model objects, which command model objects do what, because you've learned a lot about this now, and maybe you're going to have an opportunity to break this up by sort of approaching the restructure another way. Yeah, so finally this is where we want to go, right? And the reactive rework then, so we go from squares here to circles. This is where I think we ultimately need to be. But again, when you've got like, 7 or 8 language concepts in a bounded context, it's probably pretty easy to turn these simple blocking objects into actors. Okay. I mean, I think it is, but I don't know. It probably would be for you too. Now, I just wanted to point something out about the Lingo platform. I was having a conversation before about published language at DDD. Already wave at me. Yeah, there you are. Okay. So my experience with national and international standards or industry standards is not very good. I was trying to think of, maybe some of you here know what I'm talking about. I was trying to think of a standard for e-commerce order exchange. So I have order data, like an order has been produced at this service, and I need to exchange, I need to give that data about the order, maybe to fulfillment. And it starts with a G, I think. Does anybody remember what that's called? G, wow. I just can't, I think because of my bad experience with it, my brain just refuses to remember the initials or the name of it. But here's what happened, right? So you could literally place an order on an e-commerce system that had no more data than you see right here. And this is not an order data. I'm just saying that this order has no more information than you see right here. And you had to use 350 classes and instances and even multiple instances of those classes to communicate this much information across the wire using this international accepted e-commerce format. And I cannot believe actually that the senior VP of development required us to use this, because I could prove, like 70 different ways that that was the wrong thing to do, including the 2 weeks that it took just to implement the classes in Scala. You know? Because like you just had to start from a sort of DSL specification, and I actually ended up writing a parser generator that, you know, basically a compiler of the spec that generated the classes, because there was no other, you know, easy way to do it than just, you know, manually type this out. So here's what I think. A published language, typically to me, in domain-driven design, and I don't have, you know, like the world of experience of every single possibility of every published language, but I probably have used a few, you know. You know, in medical, for example, ICD-9, I guess it's ICD-10 now, and, you know, stuff like that. So I've dealt with a few published languages, but I think the ones that sort of work best are the ones that you can say in a single microservice or a bounded context, this is our published language. This is our contract with the outside world. This is what we agree to disclose about what we're doing, right? And in this, you know, I teach this as part of my workshop, and we have this peer-to-peer business called Done by Me. It's where we, you know, sort of match make clients with workers who will do the work that they need to have done, maybe around their house or something. And this is the matching context that we're working in, or the matching microservice. And we published some domain events out of that. And these are the domain events that we published, some of them. But notice that this specification has a namespace, okay? And this namespace is code done by me matching. And then each schema, so each of these things that it's divided by lines here is a different schema, and each of them has one or more versions. And the contract that we want to have with the outside world is we say, we guarantee you that if you make yourself dependent on any one of these versions, we will fulfill the contract with you. We will give you the information as part of this notification that says this happened here, like a proposal was submitted or proposal pricing was rejected. And we say that if you depend on version 1.0.0, that's what you get, right? And then we say, by the way, if we ever have to update the proposal permitted or submitted or change its definition, we agree that if we only change the minor version, so this is a semantic version, right? Major, minor, and patch version, we have an agreement with you that says if we only make a minor version update, we will not break you if you decide not to use version 1.1. If you decide to continue to use version 1.0, we will not break you, okay? But now, you know, something comes along called, you know, oh, what is it? Saying it for 3 days and now my brain won't say it. GDPR, right? GDPR, is that right? GDPR.
Yes.
Ooh,
DSGVO.
yeah. So, what is it?
DSGVO in German. Datenschutzgrundverordnung.
All right. Okay.
Not one word.
Okay, so along comes this new law, and we can't disclose certain information to the outside world in our domain events. And so what we say is, as of May 25th, 2018, we are only going to publish 2.0.0, but because we have a major version change, we can make breaking changes. But that's because the law requires it. So we're no longer going to publish the information, all of the information that was available back then. We may even provide that information in some sort of a, you know, a way that gives you a way to find out if you need to what it would be, or if you have the rights to see it, but we're just not going to tell you the actual information. So this, I think, is a really important way to make a contract with the outside world. Yes, I am fully aware of Consumer-driven contracts, this is sort of the opposite. This is the outside world saying, you will, right? You will support this information exchange for us, and this is saying, well, this is our published language, and this is what we're willing to share with you. So if you need something else, please make a recommendation. And this thing called Lingo Schemata is a schema registry. This is the whole idea, and it doesn't just support events. It supports, documents, regular old data definitions, and it's all using a definition language that's neutral, and so we could generate classes for Java, for C#, for Ruby, for Python, for, just keep on going. And we can generate serializers for all kinds of serialization formats and all that, depending on what kind of information we exchange here. So that's a pretty important piece of the puzzle in doing this. And another thing that I have to say is, what one of the biggest problems with an event-driven architecture is? It's not even necessarily the types. It's that, that consumers are consuming these types. It's actually sort of the other way around. It's like, who is dependent on us? So you can imagine that if you make a contract to support this, one of these, events or documents or whatever it is that we decide to define in this schema registry, that we should know actually who's dependent on us. So that if we do make a breaking change, wouldn't it be great if we could inform that team or those teams that are dependent on us? So I'm not going to take too much more of your time here, but I encourage you to maybe look at the Lingo platform. This is the architecture from an actor standpoint. From here, everything across the Lingo platform is actor-based. The HTTP server supporting REST is actor-based. The lattice is the actor grid, where if you're working in a cluster, your actors are distributed across the cluster, and the lattice is what gives you that support, as well as 3 different kinds of persistence, including event sourcing, CQRS, stateful, and also OR mapping, all completely asynchronous, and Lingo streams. And so, yeah, if you want to go look at lingo.io, you can see that, or go to github.com/Lingo, and that's the Java version. If you go to github.com/Lingo-net, that's the .NET version, which is lagging a bit behind the Java version, but we're making good progress on that. So, if you want to check that out, that's cool. Okay. So, actually, I've got some books to give away, and I've got 4 T-shirts, and also there are some stickies, some stickers back there if you want to grab a sticker for your machine or something. So, I've got a couple books to give away. Who would like to ask a question about what I've discussed here? And you could get a book. In fact, you will get a book.
Oh, we already have a question there?
Okay, this might be a bit off topic for most people here. I've recently looked into functional programming, especially Elixir, where actors are considered a first-class citizen. Do you think that this type of technology has a lot of potential to grow in the face of these design decisions?
Yeah, so actually there's, Dimitri is sitting right here. We're friends, and he's helped with the Lingo platform, but he loves Elixir and he loves Pony language, and I think you should talk to Dimitri about that after, you can wave at him. He's here with this really cool shirt. So you can talk to him about, which book do you want?
Green or red?
Which one's better?
None of them.
Well, actually, it's like the 3 bears. This one's too hot, this one's too cold. If I had a third one, it would be just right. So, I don't know, but you gotta choose.
I'll take the red one.
Okay.
I have a question. I see a lot of very nice frameworks, and what is very important for me and my client is how long do you support this software? Because when we write software, it's will last perhaps for 5 or 10 years or something like that. And we introduce this pattern or this framework, and perhaps after 2 years you have no contributors anymore working for that. So that would be a great mess.
Yeah, but that's why you have to give us money. I mean, that's the simple solution. You give us money and we support you. But nobody's making money on this right now. So, but yeah, I mean that's it, right? It's open source, and you can go use it and see the source code and debug it and whatever. It's all yours. But if you want support, that's how it works.
Who do you consider competition to this? Oh. Who do you consider competition to this project?
There is no competition. I mean, there are other actor toolkits and so forth, but they're all non-fluent. I mean, if you're okay with every single interaction with the model saying something.tell, 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 that's just not fluent. And other toolkits force you to use event sourcing. Most clients that I work with don't want to use event sourcing. They're really comfortable with OR mapping and other, I'm not saying you shouldn't use event sourcing, but we give you 3 choices, right? So there are 3 persistence options, and they're all completely actor-based, all asynchronous, non-blocking. So, well, of course, they block at the database request, but we're not blocking your other stuff going on.
Is he eligible
Oh,
for
yeah,
a t-shirt?
Yeah. T-shirt. You want a Lingo t-shirt? Yeah.
Okay.
Yeah.
This is big enough.
It's large. Is that? Okay. Good question.
So, do you use something like Akka in the background or something? Is it built on? Is Vlingo built on top of it or something, or do you use? No.
So if you know me at all, you know that my 3rd book is actually a Scala Akka book.
Oh, okay.
Yeah, and so it makes you wonder why I'm doing Lingo right now, right? And
Yeah.
that doesn't use Akka at all. So,
Okay.
good question. Thanks for giving me that opportunity. This is a large. You want a large of Lingo? That means you gotta check it out.
Thank
Okay.
you.
The 3rd book was the enterprise integration patterns done with Scala and Akka, something like that.
Yeah.
Ringo
Well,
Hoppe was actually at the meetup.
Actually, so what you can do is, if you want to get that book and read it, you can go to the Lingo examples and see all those patterns implemented as Lingo now.
Okay.
Yeah.
Does it kind of look like Akka, like the revolt?
Well, not really.
But Akka is not Typesafe. So
Okay, yeah, that's yeah.
And anyway, I didn't come here to talk about that, honestly. So yeah, you can go ask them if you want. They'll sell you anything.
I have a question about the reactive controllers, the resource handlers. So when do you actually return to the client? So you said they're non-blocking, but what would you do about persisting the request data? So
You don't. I mean, so you get a request in your resource handler, and you simply, generally what you're going to do is just look up an actor, and when you get that actor asynchronously, you dispatch to that actor, and then eventually you get some outcome that you're going to use to respond with. That's all happening asynchronously, but because you've registered these lambdas, right, that functions that will get used once things start happening from the other side of the, some other thread, then you will eventually see a result, and you simply,
if I may ask a follow-up question.
Okay.
So when exactly will the client know that you received the message and will process it certainly?
Yeah, so rerun.
Money.
Wow, I said a lot. Okay. Yeah, so say this is a resource handler. Right here is where the response will get, provided, and we're responding with an OK, so that's a 200 and a resource representation, right? Now, but the thing is, right, the client side is a completely different world. If you have implemented your client side with a blocking HTTP, client, like HTTP client, right? The traditional HTTP client in Java, you'll block. But we don't block. In other words, whatever thread was being used right here when this happened is no longer being used. As soon as this request is made, that thread that was running this is running something else now, right? And then once that actor is made available from the lookup, we get another thread that says, okay, now you can do this, but then that thread is given back, to the pool, basically, and so it just keeps happening like that. So we're not blocking, but eventually we will have a response. But the server works in such a way that it doesn't require you to respond immediately. We simply hold as any request response, a HTTP server would, we just simply hold the connection open until this happens. Now, if the client decides to use a Lingo HTTP client and not block, then it can set up a completes with the client side, and it will get an eventual response, right? It's literally just, right, the same pattern over and over again. By the way, this is all complete stuff. So if you were to look at the method signature for actor of, it returns a completes T. The T is, actually a dynamic parameter that's passed in. This is a completes T. This is a completes T. This is right? Everything is a completes T all the way down, and you can write your client in the same way. So basically, you register your functions with this completes. And it doesn't matter if this doesn't happen for 5 seconds on the client side. You don't see not that would happen, but in other words, if 5 seconds passes, you just have these functions registered, and whenever the response is seen, right? That's when that code will react to that, right? Which let me see. Medium or large? Medium or large? Medium, please. Wow.
So now we need a large question.
Or someone who doesn't mind wearing a baggy shirt. Okay, come on. Noch ein, whatever. Frage. Noch ein.
Sehr good. Well, the thing is, I'll second that professor and ask, how easy do you find it to actually convince developers to work like that? And like, not the younger ones, not the ones working for startups, but like,
Well, let me answer that question by, this way, okay? I mean, I wasn't expecting to go there right now, but if you don't mind, I mean, since there's beer and everything, I'll just take a few more minutes. Oh, this is. Okay. So I saw this tweet September 18th, is that right? Yeah, September 18th. This is Dave Farley. You know who Dave Farley is? continuous delivery, Martin Fowler's signature book. Worked on the LMAX architecture, worked for LMAX, made that spin along with Martin Thompson and Michael Barker. So, yeah, these guys know a lot, right? Again, it's sort of like Pat Helland, you know, don't listen to me, listen to these guys, right? So, Dave Farley's having this tweet exchange with someone about, and I think they're sort of defending that they want to use Python, right? And how Python is not only good for command line tools, but Python is great for application development. Dave Farley says, okay, you know, true, but I can't think of many other fields of human endeavor where a 50x loss of efficiency is acceptable for ease of use. Says our attitudes toward efficiency in software are weird. You know, like, I hope you're not insulted by that, but you don't have to be 25 years old to understand, you know, that. And the argument gets better, right? But what I did is I saw this weird word, you know, our attitudes are weird, and it brought back this memory of something that Donald Knuth said, right? Donald Knuth said, and I tweeted in behalf of Lingo, of course, right? And I said, and I just quoted Donald Knuth. People who are more than casually interested in computers should have at least some idea of what the underlying hardware is like. What is the underlying hardware like today? We have many cores, right? I mean, this is a 4-year-old machine, and I have 8 cores, right? It's a Mac. I mean, it only has 16 gigs of RAM, but it has 8 cores, right? And so they should have at least some idea of what the underlying hardware is like. Otherwise, the programs they will write will be pretty weird. Donald Knuth, yeah. You know? I mean, that sort of says it all, right? So I quoted Dave Farley, and Dave Farley liked the tweet. And then Dave Farley replies again, because this guy keeps going about Python. And again, you know, like, there's nothing, like, I'm not going to bash Python. I barely know Python. I don't know enough about Python to be dangerous. You know, I fixed some DevOps tools that were written in Python, and that's all I've done with Python. So I don't know anything about Python. But Dave Farley says, except that if the runtime of your program is 1 second and you can complete it in 1 millisecond and don't, you are producing 1,000 times as much CO2 as you need to. Tiny for your application, but significant on a global scale. Software efficiency is a first-order concern. I mean, you know, we can't help what cryptocurrency is doing to our planet. I mean, I don't know. But, you know, we can still help where we can, right? So you don't have to be 25 years old to understand that. And I will guarantee you, if you can write, you know, if you can create a UI for a message-driven desktop, you can use actors. It's the same thing. It's really the same thing.
I just wanted to add to that, to how to convince people to use that. It's unfortunately what I built was a system based on Akka, so sorry for that.
I have too.
I guess it's the same principle applies there. So if you build a system and it survives a major outage, as pretty much the only system that just idles around and waits until the rest comes back up, because it's not built async and reactive, then
Yeah.
it's a pretty good point to make.
Yeah, and yeah, I mean, that's the thing, and like I teach in my workshop, you use messaging because it has latency built in. You do not expect request response to complete at any specific time. You just say, this needs to happen or this did happen, and then you're just idle. You don't have a thread, you're not you're not using any resources until that thing completes, and then you know it completes and you do something in reaction to that. It's reactive. And also, something else about resiliency is the actor model, including Lingo, has supervision, and so there's a way to either have a hierarchy of supervision, or basically what you do is you just say, I would like to be supported by this standard supervisor because I'm this type, and this supervisor knows how to handle failures of my type. So so there are various options, which is actually more Erlang than you get. So I took some lessons from Erlang, and that I think you'd agree Erlang's pretty good at all this stuff.
If I make a mental note, thank you, and I reserve the right to actually use that, the same arguments you talk to colleagues there.
Cool. Yeah, good. Okay, well, I'm out of T-shirts and books,
But we still have 3 questions left.
Oh, I'm perfectly fine.
If there are still more questions, so normally we don't give out T-shirts for questions as the audience still asks questions.
Okay.
Okay.
I'm currently reading Refactoring, the 2nd edition by Martin Fowler. And just yesterday, I was reading about optimizing your code. And the most important rule for that, according to that book, is to use a profiler so you know where to optimize, otherwise you're wasting your time. And in the context of this tweet, I can't help but think about trying to profile where our CO2 expenses lie and to optimize in the correct place. So I feel like this 1000x number looks really scary, but I have this suspicion that the impact is actually not worth the effort that we would need to expend.
We're talking about one operation. I mean, there are billions of operations performed every, second or something. So, I mean, cryptocurrency is ruining our planet. So
I agree with that, yeah.
And so I don't know. Extrapolate from that and just.
The hype is over now.
What is it?
The hype is over for Bitcoin.
Well, maybe that'll do something. But sorry, I don't mean to insult any cryptocurrency people here, but yeah, it's a problem.
So I have a question. What's your take on the maturity of the Lingo?
Yeah, well, we're actually, we have one Fortune company that's ready to go into production with it. It's not actually, so currently, I'm ready to build version 0.8.2. So that seems a bit early, but I mean, how long was Kafka at 0. whatever 9 something, right? So I mean, I think the world's kind of changed, and people are using tools that are at a lower version number, and it's proven. And so actually, there are probably 3 teams now that are building production releasable software with Lingo. But I am not one to say that Lingo is, every part of it is actually production worthy, but we recently solved some really difficult problems with some crazy race conditions that you only, does anyone here really super understand the Java memory model and threading? I mean, that is crazy stuff. And even when you think you understand it, there are new surprises for you. Like, can I go on and just entertain? Because this is cool stuff, especially when you finally understand what's going on. And so here's what happens, right? The Intel processor says, oh, I'm going to predictively execute this line of code because I think it will probably happen. In fact, I can prove it will happen because it's sequential. Except what I'm not going to do is execute the 3 lines of code that happened before it until later. That last line of code that it executes happens to be a countdown latch that another thread is blocking on, And I'm only talking about tests here, because we're writing Lingo in a completely non-blocking way, but imagine you're trying to test that this code works, and the Intel processor causes this line of code to execute, and it clears a countdown latch, and the test says, okay, we're ready to assert, right? Except the values that you expect to see in your thread are not set yet. But you go back to the code that's clearing the countdown latch, and you can see those values have already been cleared, but your thread over here can't see them yet. That's crazy stuff, right? Now it's cool because I understand it, but when you first face this, literally, you can look at code for 3 days and say, there is no way that this is happening. Until you just like literally beat into your head that, yeah, in fact, Java is cooperating with the Intel processor on this thread, right, and doing something crazy for this thread, but yeah, anyway. We're solving those hard problems for you so that you don't have to, right? And that's what it amounts to. Threading is hard. If you just think you're going to go back tomorrow and start writing multi-threaded code to beat this problem, look out, right? You're going to get a lot of headaches and a lot of failures from it. So.
Okay, let's take a last question for today.
So you don't own any crypto?
Not one. Somebody, John DeGos, right? Really, I think famous guy in Scala, invited me to something called Coin or whatever, and so I accepted, but that's as far as it's gone. Yeah. Yeah. No, I don't.
Okay, thank you very much for this great presentation. As Vaughn already mentioned, there is a company behind us, MAN/Rio, the logistics flow, who is sponsoring the beer and the pizza. There is pizza left, despite being cold now. There is also beer left, hopefully still, still being cold. So just don't rush out of the door. If you have to leave, leave. But unless stay around for another beer and a slice of pizza. And see you next time. Bye.